Emostel.
Hi, this is Emmanuel Kadri, and you are welcome to Emostel Academy. In the previous video under Algebra, we talked about operands and operators. In this video, we have been talking about coefficients and something related to it, which is constants. Okay? But then, let's see how it goes. Enjoy. When you have a number like 5x, for instance, I know you must have been seeing all these x's, y's, and z's, and you say find x, find y. You're looking for what is not lost. Actually, it's as if it is not lost, or it's as if it's lost, whatever is it. But then, I want to just explain to you what these things mean, for real, okay? Now, when you have something like 5x in algebra, this number 5 that you have here is called the coefficients. The coefficients, all right? And then this here is the variable. Actually, I was supposed to just name this topic coefficients and variables. I think it goes that way. Beautiful. So now we have 5x, okay? The number 5, which is a constant number, but that has an attachment, is called a coefficient, all right? While the attachment to it, which is not a number, but a letter, or a letter of the alphabet, is called the variable. All right, so if, for instance, there is an operand here, and then there is a number like 6, or like an operator here, sorry, and then another operand 6, okay? Now, this 6 here that does not have any attachment is called a constant. This is a constant, okay? It's just a constant, or you can call it a constant number, or whatever. It is called constant because the number still remains the number, no matter what. Okay, 6 is still 6. Okay, as far as this term is concerned, okay, this is a term, like we said in the earlier video. This is also another term, okay, and then this is an operator. Okay, operator between the two terms. All right, so it doesn't matter whether this variable x is there or not. As far as we have an operator between these two, this is called a term, and this is called another term. Now, without the operator, it is still a term. Like 5x on its own is still a term, even without the operator. Okay, so which means if I just write something like this, just 5x on its own is still a term. In the background, it is assumed that the term is being added with 0 or subtracted from 0 or whatever. Okay, so that is just what we believe in our mind or in the background or the, so because this will not have any effect, okay, and it can be ignored. All right, so let's just see how it goes. Okay, I'm just like forming a model around it just for you to understand the fact that why should it be called, to understand why it should be called a term, even as there is no plus or minus there. Okay, so but however the case may be, it is still a term. All right, just with an assumption that there is an invisible plus or minus 0. Okay, so all right, let's go back. All right, so this is a term, this is a term. So I just finished explaining the fact that it doesn't matter whether there is a plus or minus there, okay? Even though it's standing on its own without this plus 6 or whatever, it's still a term. That's just what I just tried to establish here, okay? Now let's come back to here, to this place. This is a term, this is another term, this is operator between them. All right, in this term here, we have 5x. In this term here, we have 6. So you can call this 6, you can call this a constant term. All right, so this is a variable term because it contains a variable. This is a constant term because it contains a number that will not change. The word variable in mathematics simply means something that can change. All right, for instance, if I have 5x here, okay? For if, let's say x happens to be 3, okay? It means I will put it in brackets 5, 3. I'm using this bracket to separate. This bracket stands as a separator and also as a multiplier, okay? Because 5x in the real sense simply means 5 times x, all right? In another sense, it also means x written 5 times, or x added to itself 5 times. That is x plus x plus x plus x, okay? So 5x simply means 5 times x, okay? Or otherwise, from the foundation, the real sense of 5x is x written 5 times, okay? So that is x plus x adding up itself 5 times. So x plus x plus x plus x plus x gives us 5x, okay? So in the intermediate, 5x would mean 5 times x, or x 5 times. You get the whole gist. So it means x 5 times, or x adding itself 5 times. And so that's why the ideology of 5 times x came in, and then 5x, okay? So x plus x plus x gives us 5x. In another sense, you should know that in algebra, when a variable is standing on its own, it simply means that the variable is being multiplied by 1 in the background, okay? So 1x is still the same, x is still the same thing as 1x, all right? So you begin to write a number beside it from 2x upward. So in mathematics, we say x, 2x, plus another 1x, 3x, plus another 1x, 4x, and so on and so forth. But the very first one is just written as ordinary x, okay? But but in the real sense, in the background, you see it as 1x. There's an invisible 1 there, okay? So x, 1 of it stands as x, 2 of it is 2x, 3 of it is 3x, 4 of it adding each other is what? 4x, and the trend goes on and on. I believe you get that scope. So now we call these letters variable because they can assume any value. That's why we call them variable. This one that cannot change is called what? Constant. The one that has a letter, either the letter standing alone or the letter being multiplied by a coefficient, is called variable. So if I say x, this is a variable. If I say 5x, it's also what? A variable. So this is a variable term. This is also a variable term. Okay? All right, in as much as it contains a letter of the alphabet. And then remember, the letters represent unknown numbers. Or you can say, or any number. Okay? It represents unknown numbers or any number. Okay, for instance, now we can assume, let's say in this case, let's say let x be 3. Let x be 3. So when x is 3, this 5x becomes 5 times 3, and then that will give us what? 15, which means 3 adding itself 5 times. Just like in this case now, we assume now that the value x is 3. So if you have 3 plus 3 plus 3 plus 3 plus 3, then all together we'll have what? 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3, 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. And then 12 plus 3 gives us 15. Okay? So that is why we have 5. When x happens to be 3, 5, then we put 3 in the bracket. This bracket stands for a separator because it will be somehow, if I wrote 5 and 3 without something separating them, okay, it will mean something else in mathematics, which is 53. So something has to separate it for us to know that the number 3 is an entity that is coming to represent or to replace an unknown value, a value that was initially unknown. Do you understand? So now we have 5 multiplying 3 gives us what? 15. Okay? And so that is how it goes. So you can see it as 5 3 times or 3 5 times. Okay? Just like we have 5x means x in 5 places. So 5, 3 means 3 in 5 places. It gives us 15. So the real sense is that we are multiplying 3 by what? By 5 to get a result. Or we are adding 3 to itself 5 times to get a result. It, depending on how you can see it, I'm just giving you different dimensions to the same thing, but different approach or different ways you can picture it or you can view it. All right. So it will still give you the same result, however you view it, in as much as you are making the proper sense. All right. So this thing I just passed to you, this lesson that we learn here in this current video, is that whenever you see a letter, a number and a letter, even though it's Y or it can be any letter, the ideology is just the fact that this number, this letter is it represents anything that can change. It can represent any number. It represents any number. Okay? Currently, it's an unknown number. So it remains unknown until a value is assigned to it. So whatever value is assigned to it is what multiplies the coefficient to give us a result. So in some algebraic equations, we are usually asked to look for that value, provided some other things. All right? So, for instance, I just want to manage the space on the board. Okay? All right, so let me just use this space here. If, for instance, you have something like this, 5x plus 6 is equal to 16, and the question says, find x. So at this moment, x is currently unknown. But this task, you know, in the earlier task, I just supplied the value, okay? I supplied the value of x, that, okay, let x be 3, all right? Then we slot it in, and then we got what we wanted to get. In this particular case, we don't know what x is, and then we want to find out what x is. This part is called the expression. This part also, in its own word, is an expression. In its own word. All right? So, this is the equality. This is equality. All right? And then, when two expressions are separated by an equality entirely, we have what? Equation. So the whole of this is an equation. So when there is no equality, it is called an expression. When it involves equality, it is called an equation. So if I had read this one I wrote earlier, everything here, the complete sense of it all here, is an expression, because it has no equality. When equality comes in, it becomes an equation. You get that? So this that we have here is an equation. So now, provided an equation 5x plus 6 equals 16, and the question says find x. How do we get it? To get the value of x, we just have to collect what we call like terms. You see, collection of what? Of like terms. I told you earlier that this is a term, this is a term. Even here too, this is also a term. This is a term, a term, a term. As far as it is separated with a sign or with an operator, all right? So this one is also an operator, so we call it the equality operator. All right, it's also an operator. Every sign in algebra is an operator. Plus sign, minus sign, division sign, equality sign, inequality sign, all of them, they are operators. All right, so as we have this, okay, the best way to find x, the best method to find x is to collect like terms. Collection of like terms. That's what we're going to do here. Collection of like term means that the word like means look alike. All right? This term is a variable term. This is a constant term, and this is also a constant term. This is a constant term because it does not contain any letter. A constant term because it also does not contain any letter. But this is a variable term because it contains a letter. So when we are collecting like terms, it means we are bringing terms that look alike. We are bringing them together. All right? So, but there is a rule in collecting like terms related to something I discussed with you in the previous video. All right? The rule is that anytime you move a term, any term whatsoever, anytime you move it to another side of the equation, whenever you move a term to the other side of the equation, that sign that precedes the term changes to the opposite of it. I told you that the opposite of plus is minus. The opposite of minus is plus. That is, the opposite of addition is subtraction. The opposite of subtraction is addition. Now, currently, it carries the addition sign. So by the time you move it to the other side, it becomes subtraction. So the rule is that whenever a term moves, all right, the sign changes. Whenever a term moves to the other side, not just ordinary movement. If the movement is within the same side of the expression, okay, the sign will not change. But if the movement occurs from a side of the expression to, and it crosses the equality sign to join another expression on the other side, the sign must change. So if it was plus 6 here, by the time it gets to the other side, it becomes minus 6. So we are going to rewrite this as 5x is equal to 16 minus 6, because the plus 6 moves to the other side to become minus 6. If it doesn't happen that way, we are not going to get the correct answer. And remember, I told you towards the end of the last video that when we move the opposite direction, the operation will change. So if we produced a result with addition, then going to the other side, as in going the other way around, will be by subtraction. If we got a result by multiplication, going the other way around will be by division. All of these things are significant to getting the correct answers in algebra. Now, if you have 5x is equal to 16 minus 6. So if you repeat this again, 5x will be 16 minus 6 is what? Is 10. And now, here we go. The rule comes to play again in this case. How? 5x means that I am multiplying 5 by an unknown number, but I got 10. After I multiplied 5 by a certain number, I got 10. In order to find what the number is, okay, which means that the operation that produced 10 was multiplication. The operation that will do the other way around is going to be division. Okay, 10 was produced by a multiplication operation between 5 and x. So if we want to get this value x, so it's as if we are just rewriting this as 5 multiplied by x, okay, gives us what? 10. That is to say, a multiplication operation yielded these results. Then a division operation is what will yield the results in the other way around. So this guy is going to excuse us here. I believe you are following through with the whole thing, okay? So we have 5x equals 10. So if we are going the other way around, we are going to divide, okay? Either the other way around from 10 to 5 or from this to that, we are going to divide. Now, this x here was multiplying before. By the time it gets to the other side, it will divide. So we are going to say all this 5 was multiplying x before. By the time it gets to the other side, it becomes division. All right, so this time around, I want just x to stay. So I will say x is equal to 10. You know, 5 was multiplying x before. This time around, on the other side, it will be dividing. So we have, because we are sending 5 to the other side, okay? Before, the relationship between 5 and x was multiplication. So whenever it comes to multiplication and division, All right, the two operands, they share the same operator, and then the operator between the two of them is that they qualify to own the operator. In this case here, when it comes to addition and subtraction, it is the number that follows the operator that owns it. Okay, the number that follows the operator owns it. I'm going to clarify this in another example, but in this particular example, okay, just know that both 5 and x are entitled to this multiplication symbol. So by the time any of them goes to the other side, they will go in form of division. So we have x is equal to what? So 10 divided by 5, that is, we count 10 and then we want to group them in 5s. How many groups will we have? We have what? 2. So it is 2 groups of 5s that will produce what? 10. So 10 divided by 5 is what? Is 2. Okay, for those of you learning elementary mathematics, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many 5s do we see there? 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 2. I remember we did this back then in elementary school. So, which means 10 divided by 5 gives you what? Gives you 2. And that is just it. So if you still have any question or there's any part of it that is not clear to you, you can send me an email or you send a WhatsApp message through the phone number appearing on the screen. In the next video, we'll be having more examples as per how to operate, how to carry out these kinds of operation to find unknown values. And you will also get to learn a few more things in algebra. The more of all these rules that you understand, then the more mathematics becomes easy for you to deal with. See you in the next video. Bye.